So these are the notes for section 1.1. So first we're going to do a lot of the basic vocabulary because that's what chapter 1 is, the basics of geometry. So the first section is the vocabulary part. So a point. So a point is a location with no size or shape. So even though they have no size or shape, they can still be represented. We typically use a dot for a point, and it has a capital letter. So one of the things you're going to notice in geometry is uppercase and lowercase letters really make a difference. So all points have a dot, and next to it is an uppercase letter. So if I actually go to name this, I could name this point A, or a lot of the time, if you just write the capital A, I also know that represents a point, and we can do that for B and C also. So a line is made up of points with no thickness or width. They are also what's considered endless, which means even though when I draw this on a paper, there's obviously a start and an end, but the arrows represent that this could just continue going in both directions. Lines need to have at least 2 points on them in order to name it, or what you'll also notice sometimes on some of them is a lowercase letter right at the end of them, and that can also be used to designate a line. So if I were to name this particular line, I could actually write out the word line XY or line YX. When you write a line, it doesn't really matter the order, or I could call this line A. That's an awful lot of writing. So similar to a point, there's kind of a shortcut version or a shorthand version, and that's using symbols. So this is exactly the same if I put XY with a line with arrows at both ends. That also represents a line. So I can do that for each of these. However, this symbol only works if you have the points. So you shouldn't actually write a line A like this. Would not be appropriate. You actually need to write line A. Line segments, or sometimes they'll just call them segments, are a measurable part of a line consisting of 2 endpoints. So unlike an actual line, a line segment is just part of it. So if I look at the line above that can keep going on in both directions, a line segment would just be from one point to the next. So a line segment can be part of a line, so we can pull it out. And it is typically just represented by a symbol. And so line XY, so notice on this one, it's just a straight line and there are no arrows. And same thing here, the order doesn't matter. So I can reverse the part of it. A ray is also part of a line. That extends in one direction. Okay, so same thing here. If I went back up to this line, a line is actually made up of 2 different rays. So if I cover up this extension on here and I just have an actual starting point or what's called an endpoint, it goes in just one direction. If I cover up the line part on the opposite side of Y, this one goes just in one direction. So if I take just the part of this down here, so a ray has an endpoint and it goes in one direction. So when you name a ray, we can write the word ray, or most of you will probably just use a symbol. So you want to start at the end point and then put the point in the direction that you're headed. And the symbol for it is just a line with an arrow at one end. Okay. I could not name this name XY is array because this doesn't extend in one direction. So array has a specific way of writing it. Opposite rays are rays that extend in opposite directions. That form a straight line. So if I have a point, if I extend in one direction, and then I extend exactly in the opposite direction and actually form a line, those two would be opposite rays. So I'm going to put a point on here so that we can easily distinguish them. So I would say that ray BA is an opposite ray to ray BC. A plane is a flat surface and extends in all directions. To maybe help understand this, think about a floor, a tiled floor. I can draw one tile to represent the whole floor because it's an example of it. So even though you're only seeing one little part of it, it can extend to be my entire paper and further. So with a plane, it has two different ways of naming it. Sometimes you will see a script letter in the corner, and I could name that plane T. Or you have to have 3 points on the plane. So I'm going to put 3 random points here. And as long as they are not on the same line, we can use the points as long as they are on the plane. So I could also call this plane EST. And here again, the order doesn't matter. So I can switch the order of those points. So I could do plane TSP, plane TPS. It doesn't really matter. Okay. The one thing that you can't do is if there is a line on there, and I end up put another point here, I couldn't name the 3 points that are all in a line to name a plane because that would be a little confusing if you just saw that if somebody forgot the word plane. Okay. These 6 vocabulary ones are ones that we will use throughout geometry. In fact, most of these you probably learned in 6th, 7th, and 8th grade. But it's just always good to go over them. Most people can identify them. It's just making sure that you are very specific on using the symbols to name them and to recognize them within pictures, which is what we're going to take a step further on. Okay, and I will post these notes on Canvas if you want just a PDF of them. So if I'm going too quickly, you can obviously pause the video if you're trying to take notes later. The second sheet in that note packet, this one is a review of the vocabulary words. So if you want a sheet that has all of them on there. So I've talked about a point, a line, a plane, a segment or a line segment, array. We've talked about opposite rays, but there's 2 words that come up every once in a while that you want to recognize, and those are collinear points. So we've talked about lines, so those are points on the same line. So co means they are on the same line. So points that lie on the same line are collinear points. So if I had a picture that had 2 different lines on it, so if I have line AB, and I have a line that goes through here, line BC, points A and B are collinear. However, if I said points A and C, they are not collinear, so we would say they are non-collinear. which means they are not on the same line. Similar is coplanar, so points that are on the same plane are coplanar. So a good example of this is if I have a plane and I have some different points on here. Points A, B, and C are coplanar. However, if I drew a line that kind of went through the top of that and through the paper, and I added another point up here, point D is non-coplanar. Okay, it basically just means that you have a point that is not on that plane. Those are all the vocabulary words that we're going to use in this first section. And like I said, a lot of you can recognize them. So basically, it's just a lot of going back and recognizing them in a more complex picture and not just individually. So we're going to work through some of these. And if you'll notice, the note packet is rather thick. I always put extras in there in case people have questions, so we can go there. Or when you're working on homework, I have some extra examples if you get stuck on one and there's only one of them on there. So here's a little more complex picture. I always say when you get a picture, let's just look at it first before we even look at questions and recognize. So on this, I recognize that I have a plane that has one line on it because it's solid, and then I have another line that's going through there that's only maybe touching at point C. So that will help me out a little bit. So to give two other names for line CD. So we know we're looking at this line because this is line CD. So the most obvious way to name this would be just to reverse it. So this could also be line DC. And then the other thing that you notice is it has a lowercase n up here. So I could also name this line M. Notice I did make it lowercase because if I used an uppercase M, that's actually the name of the entire plane, okay, which is what they're talking about. So if I wanted to say a different name for plane M, so remember when naming a plane, if I'm not just using the uppercase letter that's in the corner, that's not a point, I have to name three other points, but they cannot be the ones that are on the same line. So we know we're going to have E somewhere in this. And then I just need to choose 2 points that are on this line. So I can choose A and C, or A and B, or C and B, and I can make those in whatever order. So I'm just going to name this plane E, B, A. So I know that all three of those are on this plane. I couldn't also use plane D because remember, it's not coplanar. 3 asks us for 3 points that are collinear. So remember, co means on the same line. So those would have to be A, C, and B, and I could list those in any order. So if you wanted to put them alphabetically, you could. And then name a 4th point that is not collinear. So technically there's 2, but I'm going to use the one that's still on the same plane. So I'm going to write E. Would D technically be an answer? Absolutely, because it is not collinear with all 3 of those points. And then 4, name a point that is not coplanar or non-coplanar with points A, C, and E. So A, C, and E are all on the plane. So the one point that is not is point D. 5, what is another name for line PQ? So I'm going to name all the different ones. Sometimes they'll just ask you for one, so you just have to see what the question is. So the most obvious one is to reverse the order, so QP. And then I can use any other 2 points. So this time I'm using P and Q, so I can maybe switch and just use line PT or TP or TQ or QT. Those are all the same line. And then also there's a lowercase line, so I could also write line J. For 6, what is another name for segments? RS. Segments, remember, are a little different because they have to go from one endpoint to the other endpoint. So the only other way to name segment RS is just to reverse the order and call it SR. 7, name all the rays with endpoint T. So remember rays, this is our starting point, so we need to see. So I could go up from T, so I could do ray TR. I could go straight down from T and do ray TS. I could also go up here kind of upper to the left, so TP. And the last one would be TQ. Notice when naming a ray, I always start at the endpoint and go out from there. So it's always going to be on the left. And then which of these are opposite rays? So if I look at TR, the opposite ray, the one that would form a straight line, is TS. So these two would be opposite rays of each other. And then so would the other two, because they form a straight line going the opposite direction. Okay. Sometimes you'll get into more complex pictures. So those of you that have taken art classes know that this is a two-dimensional drawing, but it's actually a three-dimensional figure, just drawn two-dimensionally. So basically what we have is a hexagon for the base. We have triangles for the sides, and they all meet at a point. So this would be a hexagonal pyramid, and we'll learn about those second semester. So name the intersection of plane X, Y, Z. So if we start tracing X, Y, Z, that means we're talking about this whole bottom plane. You can't just stop and think just the two lines. You have to follow the plane all the way around. If it helps, you could add the 2 extra letters on there. And we want to see where it intersects with TVW, which is this one. So if we trace this bottom plane and we trace this one side, which is a triangle, they meet along this whole side. So anytime 2 planes meet, they typically meet at a segment, which in this case would be VW, or we could reverse it and say WV. 9S, name the 2 planes that intersect at segment XW. So XW is part of the bottom plane, and it's also part of this triangle. So we just need to name them. So I would name this plane X, Y, Z again. Here again, if you wanted to add the V and the W, it just takes at least 3. And plane X, W, T, because that's the side one. Okay. 10 asks you to name 3 planes that intersect at Z. So they want to know which of them intersect at point Z. So Z is part of 3 planes. Here again, it's part of the bottom plane, the hexagon. It's part of this front triangle, and it's part of this back triangle. So I would need to name it. So plane X, Y, Z, plane ZYT, and then the last plane that it's part of is ZTV. Okay, here again, any of those could be named in any different order. It's kind of up to you. Also, there are many places where at least 4 planes intersect. So if we take just any 4 of these, if I use the bottom one and 3 of them, there's no common intersection point. But if I take all of these different triangles, they would all intersect at point T. Okay, I find this really helpful to make sure you outline kind of what you're saying. If you need to use different colors, you're more than welcome to. 12 and 13 are asking you to sketch a figure. On Big Ideas Math, they don't really have you sketch your figure on there, but you would maybe want to jot it down in your paper. But they are going to give you multiple figures, and you have to be able to identify the one that matches the description. So I always tell kids, try to sketch it out first before you start looking for a figure. So line AB intersecting with ray BC at B. So I know if something intersects, they're going to meet. So I need to have a line intersect with a ray. So if I draw a ray and the line intersects it, but notice part of this where it intersects is at P. So I need to have that intersecting line go through point B. So the ray has to be BC. So I know there's going to be a point C out here. And the line is AB, which means I either need to have a point A up here, or I'm going to have an A down here. It's really up to you. It could be either direction. Okay, so each one of you might draw a slightly different picture, and that's perfectly okay as long as it still meets those criteria. 13 says line K intersecting with plane M at point E. So if a line intersects with a plane at a point, if we looked at the example that we did earlier, this has an example of we have a plane and we have a line intersecting it at a point. So we know that we're going to have to draw something similar to this, just maybe not as in depth. So if we draw a plane, and we know this is plane M, it has to intersect with a line at a particular point. So that line's kind of going to go through the paper. And this is line K, and they intersect at point E. So you would have a line, picture or sketch very similar to this, and that was what you're trying to find. So at this point, if you feel pretty comfortable, you're more than welcome to stop the video and go ahead and start on the problems on Big Ideas Math. They're under the assignment tab at the top. And it should say 1.1 practice. If you didn't finish the practice problems from last week, they're still in Big Ideas Math under assignments, but you'll have to then click on the overdue tab. I'm not going to count those late because I know people have had problems with technology or just some issues with getting onto Canvas or their iPad not working in some cases. I am going to do a few problems off of the next page, just on ones that I know people were maybe struggling with, and those tend to be the ones towards the bottom with the three-dimensional figures. So on these, this would be an example of a square pyramid because the base is a square and it's got three different sides. So notice the ones that aren't solid lines kind of just show the three-dimensional part of it. So just be careful on those. So like on this one, we have a plane R. We have basically a plane on the plane. So this is kind of part of that. And then these other ones are not on the plane, but they do touch the plane. So they would intersect at like segment YV or segment YX. And then if it asks where more than one plane intersects, that would probably be point Z because the sides of the pyramid all intersect there. Same thing with this one, it's just recognizing. So this one we have two planes, so it's like almost having my hands like this. And then I would have a line that goes through them. And then I have another line on this. So you could imagine like one of my fingers or something like that. It's kind of a three-dimensional figure, but drawn two-dimensionally. So hopefully this has helped you. Obviously, I did post another video that another teacher did somewhere else. You can also use that. You can use your book. If you're from Group B watching this, I'll see you later this week. If you're from Group A, hopefully this was a good review if you needed it or if you missed